Hello students, welcome to Learn Guru classes. So today we are going to start with class 10 science, the first chapter in chemistry, that is chemical reactions and equations. So in this particular video we are going to study about what is a chemical reaction, what are chemical equations, and I assure you that after watching the video your concepts about these topics will be very clear. So with this note, let's begin our class. Nature undergoes changes. So the changes in nature are basically of two types. The first one is physical change and the second one is chemical change. What happens when we boil water in a saucepan? So the water in its liquid state gets converted into water vapor and escapes into the atmosphere. When we consider melting of ice, the solid form of water in the form of ice gets converted into liquid form of water. When we consider cutting an apple into several pieces, the identity of the apple is not lost. So all these examples tell us about the changes where the matter transforms its form from solid to liquid or liquid to gas, but the identity of the substance is not lost or the chemical composition is not changed. Like if we consider water, when we heat water in a saucepan, so the water in its liquid state gets converted into gaseous state, but the molecular formula of water, that is H2O, remains the same in both water in liquid state as well as in the gaseous state or in the solid state. So any changes where the matter transforms its form or alter its form, but the chemical composition of the matter remains intact are called as physical change. Let's talk about some other changes. When milk is kept at room temperature during summers, we see that the taste of the milk gets altered. That is, it tastes sour. That is, milk has been converted into curd, okay, which is a completely new substance, and this process is irreversible. Bananas, when kept at room temperature for a longer time, what happens? It ripens, which is an irreversible process. When we consider iron nails, if these iron nails are exposed to water and comes in contact with atmosphere, there is a reddish brown color on the surface of the iron nails. So this is called as rusting of iron. So due this the substance that is formed due to the reddish brown color is a completely new substance from that of the original iron. Photosynthesis is a process by which plants, in presence of sunlight and water and carbon dioxide, produce their own food and liberates oxygen. When we talk about the digestive system of human beings, the food in its complex form gets converted into simpler substances with the help of the enzymes. When we consider a car, the burning of a fuel leads to evolution of some gases. So all the examples that I have told you just now, so these examples tell us about a new substance that is formed from the original substance, which is different from the original substance in chemical identity. Okay, that is, the chemical composition of the substances are changed. Like when we consider rusting of iron, that is, a layer of iron gets converted into iron oxide, a layer of iron oxide gets deposited on the surface of the iron and hence it turns into reddish brown color. So iron oxide has a different chemical composition from that of iron. So the changes where the alteration of the chemical composition takes place or alteration of the identity of the substance takes place and the process is basically irreversible are called as chemical changes. Let's try to understand the rusting of iron more clearly. So let's take iron nails. So the color of the iron nails are basically blackish gray in color. So when these iron nails are exposed to water as well as oxygen, what happens? A layer of iron oxide gets deposited on the surface of the iron nails. So this iron color of the iron oxide is basically reddish brown color and so the entire iron nail gets converted into reddish brown color. Now, this iron here reacts with water and oxygen to give rise to a new substance that is iron oxide. So we can say that it is a chemical change because new substance is formed which is different from the original substance as well as different from the chemical composition from the original substance. So any chemical change can be called as a chemical reaction. So chemical reaction is basically defined when two or more substances combine or react with one another to form a new substance that has different chemical properties and different chemical composition. Now, when we talk about chemical reaction, some changes occur during the course of a chemical reaction. Now, these changes may occur in the form of change in state, change in color, evolution of a gas and change in temperature. So let's talk about them one by one. So first one is change in state. So let's talk about the digestive system of human beings. So when we consume food, we consume food in the form of solid. So this food with the help of various enzymes gets transformed into simpler substance which may lead to a changing state of the food. Now, when we talk about change in color, let's consider the famous case that is rusting of iron. So, the grayish black color of iron due to chemical reaction gets converted into reddish brown color. Now, about evolution of a gas, we need petrol and diesel to run a car. So, due to the burning of fuel or that is diesel or petrol, evolution of gases like carbon dioxide and carbon monoxide occur. And when we run a car for long, we see that the parts of the car like engine gets heated up. So we can say that due to the chemical reaction, change in temperature occurs because burning of diesel or petrol is called combustion and that is nothing but a chemical reaction. Let's try to understand chemical reaction more clearly. So for this, let us take an experimental setup where we add some zinc granules to a conical flask. Now, to the zinc granules, we add dilute sulfuric acid. So, as soon as we add some dilute sulfuric acid, we notice some changes as some gases come out from the cork of the conical flask. So, what has happened? Basically, zinc has reacted with dilute sulfuric acid to form zinc sulfate and hydrogen gas. And this hydrogen gas has escaped from the cork of the conical flask. So we see that the original substance that we have used, that is zinc and dilute sulfuric acid. So the new formed substance is zinc sulfate and hydrogen gas. So we say that a chemical reaction has taken place here and thus given rise to a new substance, that is zinc sulfate and hydrogen, which has different chemical properties as well as different chemical formula or composition from that of the original substance. So basically, the substances that take part in the chemical reaction are called as reactants, and the finished products or the new substances that are formed are called as products. So from this experiment, we see that due to the chemical reaction, evolution of hydrogen gas has occurred, that is hydrogen gas has escaped from the cork of the conical flask, as well as if you touch the conical flask, you will see that the conical flask is hot, that is a change in temperature has also occurred. So these are some of the changes that we see when a chemical reaction takes place along with the formation of new substance. Now, instead of saying the entire experimental setup which we have discussed just now as when zinc granules reacts with dilute sulfuric acid, it gets converted into zinc sulfate and hydrogen. So if we replace this sentence with this form, then I think the means it is more easier to understand, simple as well as concise. So the left hand side of the arrow gives us information about the reactants that take part in chemical reaction, and the right hand side of the arrow gives us information about the new substance formed, that is the products. Now let's take another example and tell the entire sentence like, when magnesium ribbon is burnt in oxygen, it produces magnesium oxide. Now instead of telling the entire sentence, if we try to represent it in this form, so I think it is more easy to understand, simple and concise. So here also the left hand side of the arrow indicates the reactants and the right hand side of the arrow indicates the products. Now another way of writing a chemical reaction is by writing it in the form of symbols or chemical formula. That is, instead of writing the whole name of the chemical reactants like zinc sulfate or magnesium oxide or dilute sulfuric acid, if we can represent it in the form of symbol or chemical formula, then the process becomes much more easier. So let's take the first example, that is when zinc reacts with dilute sulfuric acid gives zinc sulfate and hydrogen gas. So this can be represented as Zn, that stands for zinc, plus dilute H2SO4, that is dilute sulfuric acid. So these reactants react with each other to give the product, that is ZnSO4, which stands for zinc sulfate, plus H2 gas, that is hydrogen gas. Then another example, that is when magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. So Mg here stands for magnesium, plus O2 stands for oxygen. So both of them reacts to give magnesium oxide, that is Mg. Now let's take another example as calcium carbonate. When it is heated, it gets converted into calcium oxide plus carbon dioxide gas. So CaCO3 here stands for calcium carbonate, CaO stands for calcium oxide, plus carbon dioxide stands for CO2 stands for carbon dioxide. Now here another important thing to note here is that within the bracket here the state of the reactants or the state of the products are mentioned within the bracket. Like CaCO3 within bracket it is S, means CaCO3 exists in the solid state. So after reaction it forms calcium oxide. So calcium oxide also exists in the solid state and carbon dioxide is a gas. So this type of representation also gives us information about the state of the reactants or the products. So it helps us to understand chemical reaction more better, as well it is more simpler to understand and concise. So chemical equations, so this type of representation we call it as chemical equations. So chemical equation is nothing but a symbolic way of representation or a way of representing chemical or reactants or products in the form of chemical formula or symbols. Now another thing to note about chemical reactions or equations is that the number of atoms that take part in the reaction, like number of atoms in the reactants, should be equal to the number of atoms in the products. So if this is so, we call it as a balanced equation, and this is the first and foremost requirement for a chemical equation, that a chemical equation needs to be balanced. So now let's take some examples and try to understand whether the equations are balanced or not. So let's take the first example, that is Zn plus H2SO4 gives ZnSO4 plus H2. Now let's calculate the number of atoms in the reactants and the number of atoms in the products. So we see that zinc, that is 1 atom, H2SO4, that is 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen, that is it gives 7 atoms. Now 1 plus 7, that is 8. That is 8 atoms are there in the reactants. Now let's go to the product side. So what happens? Zinc sulfate is formed plus hydrogen gas is formed. So zinc stands for 1 atom, sulfur stands for 1 atom and 4 atoms of oxygen, that is 6 atoms of zinc sulfate, plus hydrogen, that is 2, that is 8. Total there are 8 atoms in the product side. So we can say that 8 atoms are there in the reactant side and 8 atoms are there in the product side. So we can say that the equation is balanced. Now let's take the second example, that is calcium carbonate. When it is heated, it gives calcium oxide plus carbon dioxide gas. Now calcium carbonate, 1 atom of calcium, 1 atom of carbon, 3 atoms of oxygen, that is 1 plus 1 plus 3, that is 5. Now coming to the product side, calcium oxide, that is 1 atom of calcium, 1 atom of oxygen, 2 plus carbon dioxide, 1 atom of carbon, 2 atom of oxygen, that is 3, 3 plus 2, that is 5. So number of atoms in the reactant is 5 and number of atoms in the product side is 5. So hence we can say that the chemical equation is balanced. Now let's take the third example, that is when magnesium ribbon is burnt in oxygen, it gives magnesium oxide. Now Mg plus O2 gives Mg. So here let's calculate the number of atoms in the reactant side. So Mg is 1, oxygen 2 atoms are there. So 1 plus 2, that is 3. Now when it gives the product MgO, that is 1 atom of magnesium and 1 atom of oxygen gives 2 atoms. So number of atoms in the reactant side is 3 and number of reactants in the product side is 2. So it is not equal, that is reactant side atoms, it is not equal to the product side atoms. So we can say that this is an unbalanced equation. So we need to balance the equation. So this balancing of equation we will be studying in the next class. So today we are concentrating only on chemical reactions, chemical equations, and what balancing basically means, or the preliminary concept of balancing a equation. So this is all about chemical reactions, chemical equations, and some tips and bits of balancing a chemical equation. So in the next class we will be studying in detail about how to balance a chemical reaction. So I am ending the class here. So if you find this video helpful, please subscribe to Learn Guru classes, like, comment and share it with your friends and relatives. So thank you so much